Good morning, good afternoon, good evening, everyone. My name is Christian Aparicio. I'm a product marketing manager here at MSC Software, and I'll be presenting today's presentation. As many of you know, we are here to discuss sort of how to expedite the process of creating geometry for finite element analysis, where you do a strength analysis. And then I'll also make a few comments regarding how this same geometry could be used for, say, an injection molding process. Just to give you an introduction to myself, I've been here at MSC Software for over 5 years. I have a background in structural engineering from the University of California, San Diego. A lot of my responsibilities here are to communicate some of the best capabilities in our software applications so you as an engineer can better leverage these solutions in your everyday workflows. Throughout the presentation, there will be a poll open, and you're all more than welcome to participate in this poll. We actively look at the poll results, really to understand what should the topic of our next webinar be. And really, this is all meant to help you, again, in your everyday engineering workflows. Now, what are we covering today? Obviously, we're going to cover the mid-surface process. We're going to cover how to do this manually. We're going to cover this, or rather we're going to cover an alternative method where you semi-automatically do this. And then throughout this presentation, of course, I'll be giving you live demonstrations just so the concepts better communicate to you. Here on the right is just an example of a mid-surface model, or rather a model that is characterized by a lot of thin sections. And this is a perfect example where you would want to go ahead and mid-surface. And after I cover all of this, if time permits, I'll go ahead and jump into a quick question and answer session. So if you do have any questions, feel free to submit your questions using the window located to the top of the screen. And now, just as a quick refresher, when is it a good time to go ahead and perform your mid-surface process? Here on the very left side of the screen, I have original solid geometry. You see the geometry is characterized by a lot of these thin sections. These thin sections can be expressed as a mid-surface geometry that you see here in the middle. As you'll find out, or as many of you are already familiar with, this process from going from the solid geometry to even your mid-surface geometry is a very cumbersome process. It might be characterized by hundreds, maybe thousands of individual mouse clicks, or thousands of individual steps just to finally get to your geometry. After that, you might then take additional time to go ahead and create your mesh that might be used in FEA. You might want to also assign some thickness properties to the sections too. But what about it makes it so difficult? There are dozens of things that could drive the process to an extended period of time. I've seen some individuals take a few hours to go through this process. I've seen some groups take days to go through this process, so we're all aware of how challenging this process is. Here on this screen, I just have some examples detailing why this process is so difficult. Since we're dealing with injection molded plastics, a lot of the time you're introducing or you have draft angles throughout the sections of your model. Here as an example, a lot of these ribs are not uniform in their cross-section. Here it's very subtle, but at the root you can see that it's significantly, or very subtly actually, wider than the end of the rib, if you will. And the challenge for us is to really create a mid-surface piece that is aligned to the midline of the section. And as you saw earlier in the presentation, I had an example where there must have been dozens of these ribs, all of which are using draft, all of which you have to be very careful when adjusting the mid-surface at the midplane. Here on the right, more examples of these ribs. Here, as you see me, let me actually use my laser pointer. Here as I highlight this running continuous rib on the exterior of this piece, just creating a continuous mid-surface might be very difficult. In this example, you see that the curvature at the fillet, if you will, is not curved. It's actually almost perpendicular. There's actually a missing piece here at this other curved section of the rib, and even the rest of the mid-surface is missing pieces. Fixing this in itself is a very time-consuming process, and here today I want to give you some examples of how to expedite this. Some of the examples I'll be showing you today, some of the technology is been demonstrated to really expedite the process. Here I'm just going to go over 2 examples. Here is an injection molded plastic that you'll find in an automotive or consumer good application. Previously, this is based off one of our customers actually. The process would have taken 10 hours. And just to go from your original solid geometry to your mid-surface, then the mesh, and then defining your thickness properties for the mesh. After using some of the methods I'll demonstrate today, we were able to reduce the workflow from 10 hours to 1 hour. So this is a big reduction in the time it takes you to perform your mid-surface process. The benefit to you is you can get to your moment where you perform a strength analysis a lot faster. Here's another example. The methods you see here today, are not just applicable to injection molding materials. They're also applicable to structures composed of metallics. Here's one such example where the process of extracting your mid-surface geometry, fixing all the gaps, making sure there are no free edges, and so on and so on. This entire process previously took 50 hours, but with the methods you'll see today and the technology, we were able to reduce this to 5.5 hours. Again, the goal here is to get you to a point where you can perform your strength analysis a lot sooner in your product development cycle. And again, throughout all of this, if you have a question, feel free to submit those using the window at the top side of the screen. Also, we do have a poll open. You're all more than welcome to participate in this poll. Now, let's go over some methods of how to approach this mid-surface process. Today in your existing tool, today you might actually go about your mid-surface modeling process. You might actually be using some sort of automatic method in your existing tool. I know when I first started, I was a big fan of these automatic methods, but one thing I realized really early on is the automatic methods don't really get you too far to completion. So just to give you an example, here for this example that I showed a few slides ago, when I went ahead and used the so-called automatic method in my tool, it brought me to 20% completion of the final mid-surface geometry. This is still good, but not as good because then I have to take additional time to manually fix all the gaps, make up for all the missing geometry pieces, make sure there's congruency across the 3 edges, and do all this fancy work until I can say I finally finished this. And again, this example, it took over 10 hours. Actually, let's go ahead and maybe jump to a demo right now and show you what we mean by that. Here is an example of an injection molded plastic. As you would expect, there's a change in the thicknesses of these various sections. Here, let me just show you as an example. Here at the top of this rib, you have a thickness of X amount here, 2.91 millimeters. And then when I measure at the root of this rib, if you will, well, in this case it is 2.91. But there are some regions around this piece where you find a change in the thickness. Actually, it was here. If I go from here to here, 3.96 millimeters. And if I go from here to here, that's where you see a change in the thickness. And as you'll find out in a moment, we can adequately, and in addition, quickly create a mid-surface geometry that is along the midplane of the section. So now let's go ahead and use an automatic method of extracting a mid-surface for this. I will really do no modifications to this. What I want to showcase is just sort of how incomplete the mid-surface geometry can be when you first extract the geometry without any modification. And here in a moment you'll find the creation of this green mid-surface geometry. Let me go ahead and suppress the visibility of the solid. Here in green is what we actually extracted. What you see in yellow is something I created before this presentation. But as you can see, we have a few challenges with the geometry we just created automatically. Number one, here we see that where we should have a curved section, we actually have almost a perpendicular connection of the midsurface. Here, where we should have a continuous running midsurface, we actually have a breakup of the midsurface. Here, there's a gap. Here, it almost looks like there's a piece missing in this section. This curved section is not even contacting the rest of the midsurface geometry. And these are all things that we will have to go ahead and fix in order to ultimately get to our midsurface geometry. Now let me undo the action right now, and I'll come back to this in a moment. So again, today in your existing tools, there might be this automatic method that works to some extent, but only gets you a partial amount of the way to your midsurface geometry. What I will go ahead and highlight now is the so-called semi-automatic approach that really creates geometry closer to completion. When I tried this example and what I will show you in a moment, it will actually bring you closer to completion. I'll admit not to the finish line, but enough where you only have to do a simple few edits to your geometry and then be done with your example. Here again, this was an example that took 10 hours and was reduced to 1 hour. And let's go ahead and jump into this demonstration where I show ourselves leveraging this semi-automatic method in the application. So again, there were a few challenges. Maybe I can actually show what the previous midsurface geometry looked like. What I want to do right now is maybe snap a picture of this for our future reference. And that's what I'm doing right now. And here, let's go ahead and maybe highlight some of these sections we want to address. Again, this piece is not curved. There's a missing gap, another missing gap here. So let's go ahead and exercise some of the tools in this application so we can go forward with our process. Number one, here I'm using this specialized incremental midsurface tool. The reason I'm calling it out is maybe you're new to Apex and you want to know specifically where this tool is. It's located here under Geometry Edit Tools, under Midsurface, and specifically this far rightmost icon on this widget here. Number one, you would go ahead and, or before that, let me undo this. Let me undo the tool so I start at the very beginning. You would first click your solid geometry. This creates your so-called midsurface pairs. At first, this was sort of confusing to me, but I'll take a few moments to explain what these are. Let's go ahead and address this portion of the midsurface geometry first. Here in gray, it's indicating that there's no midsurface geometry that will be created here. But after I use this edit base pairs, I can create a base pair here, and now previously it was gray, but now it's yellow, indicating there is a midsurface piece that will be created there. And just as an example, let's go ahead and extract what the new geometry could look like. Here, we're a step in the right way. We've, one, prevented the creation of this almost perpendicular section, but now we still have the issue where it created a fragmented piece of geometry. And this is something we'll go ahead and address in a moment. And just adjust the visual tolerance here so it looks a little cleaner. And right now what I'll go ahead and do is I'll undo the step I just made, and then I'll combine the pairs on the outer portion of the screen. So let's go ahead and undo this. And let's go ahead and merge these pairs. So 1, 2, and 3. And then we'll go ahead and extract this midsurface, and you'll find that now we have a nice running continuous midsurface here around this corner. So again, this is the incremental approach, or the so-called semi-automatic approach. Previously, if we just did an automatic approach without modification, we resulted in the shown midsurface geometry. We had a perpendicular connection, a missing gap here and here. You can see the stray midsurface was even problematic to us. Here, what we've been able to do so far is actually fix this continuous midsurface here. Let me actually delete this and we can continue with our example. Now again, I can do the same for this. I can create a pair here. And when I actually do go ahead and create a midsurface piece, I have a confidence that there will be a continuous midsurface here. But again, we still have the issue where we have to merge these midsurface pairs together. And here, let me merge all of these together. And you know you're merging when they turn golden like this. And then after you confirm the edit, they all become one color, indicating they are one continuous pair. And now when I go ahead and extract the midsurface, we now have a running continuous midsurface throughout this rib. So let me go ahead and take a step back. Let me actually go ahead and leverage these tools to create a midsurface pair here. Here's a point in the model where you will like to go ahead and create a pair, but you get prompted saying that this face or its opposing face is already sharing a pair. But that's okay. What I can do here is I can select that pair and update the pair so on the other side it's actually including this face in the pair. You can see that now highlighted in red. Here on this other corner, I'll create a pair like before. The next button here, again, is going to allow me to create one continuous pair. Let me go ahead and select all these pairs on the outer perimeter. And there we go. Now when I go ahead and extract these two midsurfaces, you'll find we get one nice continuous midsurface along the outer rib. You'll find that generated in a moment, as you see here on the screen. Now, of course, our work here is not complete. This brought us up to 80% completion of this model. Now what we have to do is fix a lot of the gaps that you see here on the screen. There's a gap between here and here. Maybe it might be worth showing the free edges in this model. So here in red, you find all the free edges. I'm going to actually make this purple just so it's a little clearer when you see it on the desktop. So we have free edges here that we can go ahead and remedy, and I think I'll do that right now. Let me first drag all of these midsurface geometry pieces we created into one part. And now I'll go ahead and use this extend surfaces tool that's going to allow me to just extend a lot of the appropriate free edges. So free edge 1 will be extended to meet the face here. If there are coincident free edges, the application will consolidate those and make a congruent edge interface there. This is very important so you avoid the events where you have duplicate nodes when you go ahead and mesh. And right now we're just letting the application do this extrusion or extension for us. And we can do a few other things. This additional piece that you see here at the bottom, we can trim this piece, as I'm showing here on the desktop, and we can delete whatever's left over here. Here are a few free edges that didn't extend, but we can easily use the tool to drag the edges, as you see here on the desktop. Keep in mind while I'm doing all of this, I'm not having to struggle with a lot of forms in the application. I'm not doing a lot of clicking, typing in edge 1, edge 2, edge 3, extend to face 1, A, B, or anything like that. Nothing exotic here. You find how flexible and streamlined the process is here in the tool. And after I complete my midsurface geometry, of course you'll want to go ahead and mesh this. So I think right now I'll go ahead and take a few moments and maybe do this. So since we're approaching the midway point of this presentation. I think I'll go ahead and continue the PowerPoint, and then I'm doing this just so we can get to a more elaborate example in a moment. So here, just in case this detail didn't come across, this application is specialized for injection molded plastics. Again, you have a lot of geometry that might be curved. You might have a lot of ribs where you need a continuous midsurface. You might have sections that are not constant in thickness. And these very thicknesses are very special because you need extraction methods that can create your midsurface geometry at the midplane. Here in the animation, I just have a quick video demo showing you all the examples we can address with this midsurface extraction method. Here on the right are the various other examples that we can also address. Some of these are very common in injection molded plastics, and what I want to do right now is give you the confidence that you can use this tool to rapidly expedite the process when it comes to creating your midsurface geometry for your plastics. Now, let's go on and move on to a more realistic, more elaborate example of the midsurface process. Right now, this piece has over a dozen individual ribs. There are a lot of issues initially when I took a look at this model. I will actually go from the very beginning and go all the way to the mesh. And then if I'm lucky and I have enough time, I'll go ahead and have a discussion of how to automatically create thickness and offset properties for the mesh. Now let's go ahead and jump into the demonstration. And let's go ahead and actually let me show this assembly. And here, let's start off with this example. This red piece is the example I want to showcase for the next few minutes. Let's go ahead and start off with just an automatic approach where there is no modification to the process. Let me go ahead and do that now. Here in this other model that you see on the screen, I'll use this example to compare sort of the semi-automatic method, and then I'll use this other session of Apex to show just the pure automatic method. I'm going to show how the automatic method doesn't always bring you something that is complete. And then I'll show this on the left, and then on the right I'll show you an approach where you use a semi-automatic method where it can be very beneficial to us. So here, let me just minimize this window and get my bearings here. So here on the left, again, this is our cells here on the left using just the automatic approach for this demonstration. You can see there are a number of issues with this model. Here, if I look at this piece of the model, we don't have a nice continuous midsurface here. Here, again, there's not a nice curved continuous midsurface. There are even a few gaps here. This entire piece of the underlying structure is completely missing, so this is something we have to complete. And again, as you inspect this model, there's just a lot of pieces we have to go ahead and essentially fill in for ourselves. Now, let me jump to the right-hand example that you see on the screen. What I'll do now is, instead of just automatically extracting the midsurfaces for me, I'll use an incremental approach, or a so-called semi-automatic approach. So let's go ahead and create our midsurface pairs for this example. And then I'll go ahead and use this previous example as sort of a guideline to tell me what should be fixed. Let's first focus on this piece of the model. Again, we're missing a midsurface here. There's a piece of the midsurface missing here, and so on and so on. So let's go ahead and jump to the application so we can go ahead and start off with this. Let's reorient the model. And like before, we'll go ahead and create some pairs here at the rounded edges of the perimeter. And now when I go ahead and say view a preview of this new midsurface that I've just created, you'll find out that now we have sort of a curved appearance in the midsurface geometry. But we're not done just yet because we have to merge the pairs so we get that continuity around the edges. So I'll do that now. Again, we'll go ahead and select these pairs. And now when we go ahead and extract this midsurface, we now get that nice continuous midsurface around the perimeter. And again, this is a big contrast to just the straight automatic approach where you do no modification whatsoever in the automatic approach, and this is the ending geometry that you would have. Now what we went ahead and did in this new example, we went ahead and modified the semi-automatic approach so we can guide the algorithm to give us a good midsurface at the end. And here, just to move on with the demonstration here, there's a questionable pair here. I can edit this pair by deselecting a face. And then I can go ahead and merge these two color-coded pairs together. And I should do the same for this turquoise-looking pair. And now when I go ahead and extract the midsurface, you'll see that the geometry is just getting better and better as I move throughout this demonstration. So here it is. Let me take a step back, and you notice here I have a small issue. That's okay though, because I can go ahead and create an additional pair here. And then merge these two pairs together. And definitely feel free to submit a question. I know I might be going a little too slow or a little too fast. So you might have a question that comes up. Definitely take this opportunity to definitely type in your question, and I'll definitely get to that towards the end of the presentation. And here, we finished the work on this portion of the model. So now when I go ahead and say extract my midsurface geometry, you see that the geometry is a lot closer to completion, which is good for me because I won't have to spend additional time to make up for all of the missing geometry. And here on the left is sort of what we started off with an automatic approach that didn't have any modification. Here on the right is an example where we did modify the automatic approach, and the result is a nice midsurface that requires little modification in the end. Now let me go ahead and continue on with this demonstration because we still have to do an entire model. And again, I'll be using this other model as reference, so let's go ahead and zoom out here on the left. I noticed that there is an entire missing section here. And what I can do at this moment is I can merge these green, blue, dark blue, and sort of light beige colors together. And what this will let me do later on is it will extract one nice, large, continuous midsurface here. So let's go ahead and merge these two together. Let's actually go ahead and extract the midsurface and see what that looks like. By doing this, it's going to reveal any issues with the geometry up front. This can let me then go ahead and take action on how to remedy this. So here are a few things that initially stand out. One, there's this almost unusual midsurface that was created here. Let's go ahead and take a step back to a point where we did not create this midsurface geometry. And here what we find out is that this large color-coded pair at the bottom is actually using this rib as part of the pair. And what I can do, of course, is deselect that pair from the rest of the color-coded pair. And here's another face too. And I believe there is another one here too. What you want is for these pairs or faces to be really on opposing ends of each other. So now after the modification, after I go back and extract the midsurface for this pair, you'll find that additional midsurface that was just hanging out in space is no longer there. Now this is good for us. This is getting us closer and closer to a point where we can just connect all the midsurfaces together and get our final result. Let's go ahead and refer back to our example. So we fixed this region where we didn't have a midsurface piece. Now we have a few issues here. We have a midsurface piece that goes beyond its boundary onto the other piece. We have a portion of the model where it's still missing this sort of corner section, and right now it'll take some time to address this. Again, you want to have pairs that are using opposing ends. You also want to prevent situations like this where you have pairs that run in one direction and then all of a sudden turn 90 degrees and run in a different section. Here's one such scenario. Here in blue, you find that when it extracts the midsurface, if you will, and then it encounters this almost 90 degree section here. Let's go ahead and remove these faces from the pair, just so we don't have this result later on. So this is good, and now we can go ahead and create a midsurface for the top face, and we can create a midsurface pair for these other walls. Now if I go ahead and extract the midsurface geometry for these pairs, you'll find out that I no longer have this missing piece in the corner like it did a moment ago. So again, we're trying to fix this piece of the geometry that you see here on the screen. And here's the final result after we modify the automatic extraction method. Now again, we're getting closer and closer. Again, these ribs were originally connected, as you see here in this example. What I want to go ahead and do now is remedy this. The reason we have this sort of issue is these pairs are the same pair. And what I can do now is deselect these pairs from every other face that you see here. So now when I go ahead and create my extraction here, you'll find now I get two individual pieces, whereas before I was getting this connected midsurface for these other pairs. And right now, let me take some time to fix this for the rest of the model. And I can do that again and again for every other rib that you saw here. All these ribs again were resulting in a pair that was continuous across the walls. Well, this is something we didn't want. So right now I'm removing each face from its original pair, and then I'm recreating a pair just for that one individual rib. And you can see in this example we actually had a number of these scenarios. And so just bear with me while I get through this process. Again, if you have any questions, definitely feel free to submit those to the QA box at the top section of the screen. I'll definitely have time towards the end of this presentation to address some of your questions. And then just my second to last piece. And with just one more, we finish the work for these ribs. And again, as you see this demo, really ask yourself, how long would it have taken you to perform some of the methods you see here on the screen? Would they have taken you a few minutes, or would they have taken you a few hours? And if it's taking you a few hours, I definitely encourage you to maybe ask how you can start the process of using Apex today. I'll actually take this moment and offer a piece of recommendation. We do have a free trial available of this application. If you're interested in using a free trial, you can go to mscapex.com. You get a 30-day free trial after you're approved for the free trial, so definitely take advantage of that. Right now, what I've gone ahead and done is I've performed midsurface extraction of another piece of the model. I like to do this in an incremental fashion. It helps me reveal any issues that might be relevant or apparent in the extraction method. Here, for example, we've created a nice piece of geometry at the midplane of this drafted angle. or drop the rib. But here we didn't extract the method, so or we didn't extract the geometry. So that's something I have to go ahead and fix in a moment. As we look throughout the model too, we find another piece of the geometry is also having a challenge. It didn't go all the way. And let me just review the model a little bit more. This mid-surface piece didn't extract too. So let's go ahead and take some time to fix this. And it'll take us back to the step where we didn't perform the extraction at all. Right now, I would go ahead and adjust the offset type. What this offset type really means, maybe I can show this, or rather, I can't do that here, but when it extracts the mid-surface, there are different ways of extracting the mid-surface. It will decide if it wants to take the outer face of the solid piece and then essentially project an inward mid-surface piece. What you can also do is select a different offset type. And so then when it extracts the mid-surface geometry, it will first take the faces of the inner region of this piece and then project those inward to create your mid-surface geometry. So that's what the offset type means. Here previously it was using what looked like the yellow offset type, and I've corrected this to be the red offset type. So in a moment you'll find the benefit of doing that. Also here, I want to join this mid-surface piece, so let's go ahead and do that. And here these gray faces are not part of a color pair, so I'll go ahead and create a pair there. I'll then go ahead and merge these two pairs together. And now after that, I can go back and extrude the mid-surface geometry, and you'll see what the benefit of that is. Let's go ahead and do that right now. And again, there were a number of problems we wanted to address here. Number one, we had a missing mid-surface piece for this running rib that you see here on the screen. We also had a missing piece. And let me go take a step back rather. Here's our mid-surface piece that was now finally created. And this part of the model you see here too, we now have a mid-surface piece. And then here in addition, we now have a continuous mid-surface piece here. And then again, I'm going to incrementally, piece by piece, discovering where I might have challenges when it comes to extracting my mid-surfaces. I can use the color-coded pairs to really fix things up front, all before I commit to a big extraction method. And now let's go ahead and quickly inspect the model just to make sure nothing stands out that should be remedied. I think right now what I can do is select the entire model. And for this part of the demo, I've done this demo before as a rehearsal, and I know that here, every now and then, you have an issue when it comes to bridging mid-surfaces at junctions, such as this one. Here, you'll have a mid-surface running this direction, another mid-surface here and here. But given the complexity of this model, what I will go ahead and do is I'll extract mid-surface pieces for all of the adjacent mid-surface or color pairs, and then I'll address these individual pieces later on. So right now what I'm doing, I'm extracting pieces for the other pairs, and here's the ending result. Let me go ahead and hide that for a moment. So this is where geometry finally looks like. I see that there is a mid-surface piece created for a majority of the ribs. Now what I can go ahead and do is fix some of these free edges, and let me change the color back to purple. This really helps communicate the fact that there are a lot of free edges here. A lot of these free edges could be issues to complete, but here let's go ahead and extend some of these free edges. And in a moment, if there's a free edge on another free edge, or there's a free edge on a face, the application will consolidate those. So now you have one, congruency across these faces, and two, you now have, instead of 54 individual mid-surfaces, you now have that reduced to, I believe, 1 or 2 mid-surfaces. And right now we're at 80% completion. You'll find the result in a quick moment. And here's the result. We went from more than 50 individual mid-surfaces and those were all consolidated to one congruent general body that you see here, me highlighting. Now, we're not done just yet. Again, there is a number of midsurfaces we purposely omitted from this process, and now I'll go ahead and address that. But before that, let's go ahead and inspect the model and see if there are any issues. Here's one piece that I want to go ahead and fix. It's just this overhanging face that is not part of the original solid, and maybe I can actually show you what the solid looks like. Here in yellow, you can act as if this is the midline for the midsurface, and here you see that we've done a great job of creating this midsurface geometry. All that's left is to create the geometry for these ribs that you see me highlighting on the screen. And I think I'll go ahead and take time right now to do this. So let's go ahead and jump back to our semi-automatic tool and display our color-coded pairs again. Or actually, let me use the manual approach. So in this method, I'll go ahead and select all of these pairs one by one. And here you see the application instantly create these pairs for me. Let me hide this geometry and actually click on these pairs 1, 2, 3. And again, all of these ribs have tapering. So the application is taking time to create a midsurface at the proper midplane of this model. Let me go ahead and show our first midsurface geometry, and you can see that we've created all the missing pieces of midsurface that we need. Now this is where it might get a little tricky. What I'm doing now is I'm isolating our original midsurface geometry, and the reason I'm doing this, I can now come back and take some of these pieces. Let me take a step back out of this. And I can begin extruding these edges that you see here on the screen. And let me go ahead and isolate the view for a moment. Again, what I want to do right now is connect all these three edges together so we can move on with the process. Now let me go ahead and display these individual pieces. And just for better effect, I think I'll go ahead and isolate these faces too. And so here are the pieces I want to go ahead and extrude the free edges so I can join these to the rest of the midsurface geometry. But here, if I were to go ahead and extend this piece, you find that there's an issue. I create this large spike in the model. The reason for that is that there's an extra vertex here. And there are a number of ways we can address this. We can take the vertex and move it anywhere that we would like. Here's an example. I want to move it there. And then when I go, I can perform my operations as I did a moment ago. But I think what I'll go ahead and do is, since there are other vertices for these other pieces, I'll go ahead and just remove these vertices all in one go. So I'll screen pick all these vertices, and in the bottom left-hand corner we get a prompt saying you've removed 15 vertices. So all these edges should have the ability to be extruded or extended with no issue. I can then bring up our original midsurface geometry. Again, let me play with the color just so it looks a little cleaner. Now what I can do is move these edges from edge to edge. So here, edge to this other edge. I'll take time to move this edge to this other face of the geometry. And then I can move this here. And I can repeat the process again and again for all these other individual pieces of the model. Keep in mind, always ask yourself the question, can you move faster in your existing tool today? Or are you having to resort to a lot of program tools where you have to pick specific edge numbers? You have to pick specific vertex numbers, base numbers, type all of those in, and you essentially do this almost in a sequential flow, again and again, click after click. And compare that to what you see on the screen, where I'm really just using the mouse cursor to move edges left and right. I'm not having to go through a lot of program tools. This one tool does a lot of the work for me. And again, we've already created 80% of the geometry, or for the most part, 80%. And it's just a matter of doing a few edits, such as the one I'm showing you here on the screen. And I'm almost done with this portion of the model. But this, after we're done with these extensions, we're not quite done just yet. There are free edges remaining in the model, and this is something we have to fix. There is a so-called stitching tool in the application. What this tool actually lets you do, if it detects an overlapping free edge, the tool will go ahead and consolidate that for you so you have congruency there. And right now I see that there is an issue with this piece. So for now, let me go ahead and extend that out just so you understand another approach you might want to have here. Let's go ahead and move all this together. And then I'll take time to go ahead and stitch all of these pieces together. Again, there are remaining free edges here at these ends, and now what I can go ahead and do is stitch all of these pieces together. So let me go ahead and drag and select all of these pieces. And now all of those individual midsurfaces that you saw a moment ago, surface 153 through 158, they were all reduced and combined to this other general body that you see on the screen. So it's now all one piece. If I inspect the model, I can see my work. And as you might expect, we're getting closer and closer to that finish line in our process. And this is ultimately what we want to do because we're being asked to actually perform some sort of structural analysis. And now we can move on. We can, at least for now, say the model is somewhat complete. I'll throw a mesh on this. And the one thing I want to show now is the ability to do two things. One, I can detect problems with the mesh. And here what I'll do now is I'll just isolate and view elements in the model that are so distorted that when we perform an analysis, we'll get a failure of some sort. That's number one. Number two, after finding regions that are problematic, I can go in with the same tool you saw a moment ago, and I can drag a vertex. Once I drag a vertex here, the mesh is automatically updated for me. I didn't have to delete the mesh, perform a geometry edit, then recreate the mesh. Here, as you see the tool, it's just a matter of me going to the actual spot, making the edit, and the application automatically creates the edit for me. And this is really handy. Again, another big time saver for you. As you saw here, I'm using a mixture of quad elements and tri-elements. You can also specify to use just triad elements. I know here in the registration list, some of you may be doing injection molding simulation where your need is to use very fine tri-meshes. You can also specify that in the application. And here, let's go ahead and look at our progress. And we'll grow the mesh, and this is reviewing regions of the model that still have a few issues that we can go ahead and rapidly fix in the model. Here, it's very subtle, but you see there's an overhanging vertex. And of course, when you see that here and there's a symmetric opposing end, there's most likely the same issue, so we'll go ahead and fix that. And this model actually does have quite a number of these, so bear with me while I fix a lot of these issues. And I know we're approaching the end of our presentation, so perhaps I should go ahead and start wrapping up. There is one thing I was unable to get to, and that is the moment where we go ahead and apply some thickness attributes to this model. This is probably something we can discuss at a later time. But right now, I definitely encourage the audience to please submit any questions you might have to the window, and we can definitely begin addressing those here as I'm finishing the end of this demonstration. Again, the QA box is located at the top of the screen. So here you see me highlighting it. There's a pull down there where you can definitely go ahead and get the questions, or submit your questions, that is. And here, I think for now, I'll just skip that. Make a quick mention of the ability to assign thickness and offset properties to this model. Let's go ahead and give this a finer mesh. This tool can automatically generate thickness and offset properties for you. A special thing about this is that it can do this automatically for sections that are non-uniform in thickness. Again, there's a lot of drafting in this example. Here, I'll select the initial mesh, and then I'll select its original solid geometry. So the mesh is the target, and the solid geometry will be used as a guide to compute the thickness and offset properties. And you'll see that it's doing it automatically for you. You also have the flexibility of manually editing specific pieces of the thickness. So here we have a color coordinated plot of what the result looks like. You find here something sort of rather questionable. In this part of the geometry, we have a thickness of approximately 3 millimeters, but here in red, we now have a spike in the thickness of approximately 8 millimeters. Again, this happens on occasion because there are sort of, if you look at the original solid geometry, there are these portions of the model where algorithm will take its best guess of what the thickness is, but due to the complexity, it takes the algorithm will take a conservative approach and give it its best guess. But here, if you find regions like this, you can go ahead and manually recalculate the thickness as an example. And here, if I display what the thickness properties looks like in 3D form, we see a number of things. Number one, we see changes in the thickness distribution, and this is really indicating that the thickness properties are in fact changing through the thickness or the depth of the ribs. If I superimpose the solid, I see that the application has in fact done an excellent job of creating thickness properties for these drafted sections of the model. And one last thing before we call it go for the demo. Again, you might be a process engineer. You might be someone who's using an injection molding tool. You might have a need to just use triangular elements. You might have a need to create really fine meshes of triangular elements. This tool also lets you create that. I should also mention the fact that you can export the geometry, you can export the mesh in PDF and file form. And this is a great time for me to go ahead and switch back to my PowerPoint and give you some concluding remarks. Number one, we can import a lot of different types of geometry. In addition to this, if you create a mesh, you want to perform structural analysis in an FEA tool. You can export a PDF file complete with nodes and elements. If you are a process engineer working with an injection molding tool, you can export ACEs, Parasolid, and STL geometry. If your tool also supports PDF file, you can also use the exported PDF file in the tool. We do support units, so if you want to go from millimeters, newtons, to inches, pounds, force, you can do that within the tool also. And as a quick reminder, if what you found today interesting, you can go to our website at msapex.com. You can click on the bright green button at the top right-hand screen, and you can come to the website and discover Apex for yourself. We have options for the free trial. We have options for lunch and learns, webinars, workshops. If you want to try this out for yourself, you can definitely go ahead and do that. And now let me go ahead and pause there and